So after seeing the basic definitions that are associated with collisions, let us go for an analysis of a one-dimensional collision. Imagine that there are two objects, and there is one object here. This is the red object of certain shape, of certain size, and this object is called A. It is moving towards the right hand side with a velocity UA. And there is a green colored object which is slightly ahead of A, also moving towards the right hand side with a velocity UB. The object itself is called B, let us say. So these are objects of some finite size, and they are moving in the same direction with UA and UB as their initial velocities. And if UA is more than UB, only then there will be a chance of collision. So let's assume that UA is more than UB. So assume that UA is greater than UB. Then what happens is that with time, this body A will keep on coming closer and closer and closer to object B, and nothing interesting happens until the surfaces of these two objects, they touch each other. So at some point what will happen is that this object A would have just gone and it would have touched the surface of B, something like this figure here. So you have A as the red object, B as the green object, and A has just gone and touched the surface of B, and still even at this point A is moving faster than B. So what I'm going to do is I'm going to probably show you velocities of these objects as perhaps the length of those arrows that represent the velocity. So a smaller arrow will shorter arrow here will show you a smaller velocity, and a longer arrow will show you a larger velocity. So A is still moving faster. So now what happens? Now this guy A will start to push B, and A will exert some force on B, and by Newton's third law, B is going to exert some force on A in the backward direction. Now those forces, because A and B are assumed to be deformable, those forces will of course make A and B accelerate, but they will also make A and B deform. So it is at this moment that A and B both start deforming. So I can say now that at this precise moment A and B start deforming. Let me write that here itself on the right hand side. Maybe, yeah. So both A and B start deforming as well as accelerating. Due to the normal forces they exert on each other. Okay. So what happens? When I talk about acceleration of A, I can have a look at the FBD of A, and I instantly know that there is a force on A in the backward direction, this force. And because of this force, A should slow down. So this vector which I have drawn for the velocity of A should start reducing in length. And there is a force on B which I know is in the rightward direction, like this. And because of that force, this force will again be F in magnitude because of Newton's third law, and because of this force B is going to speed up. So this vector, the red velocity vector, is going to become shorter and shorter and shorter with time, and this green vector is going to become longer and longer and longer with time. Now this will be the case until there will be a moment when both of these velocity vectors are of equal length, because what happens is now A was moving faster than B, and so it was trying to push into B, and until A keeps on moving faster than B, it will keep on pushing into B, pushing into B, pushing into B, and because of that push, B will keep on deforming, B will keep on deforming, and A will also keep on deforming, and there will be a state when A has got sufficiently deformed, like this perhaps, B has got deformed there, like that perhaps, and you have A and B traveling at the same velocity. Let's say that's u. So at this point of time, A is traveling at a velocity u and B is traveling at a velocity u. And now maybe at this point of time A will no longer push into B, because the distances traveled by A and B in equal amounts of time will be equal. So now there is no net deforming push by A into B. But A and B beyond this moment will try to do one of the three things which I'm going to describe. So this is the state of maximum deformation. Let me say this is the state of maximum deformation. And at this state, the velocity of A, let me not call it VA, let me just write velocity of A is equal to the velocity of B which is all equal to U. So this is what is going to happen in this intermediary state, and in fact you will see that because these two objects are traveling with the same velocity, if you take these two as a system, then this guy will also be the velocity of center of mass of A and B. So this is velocity of center of mass of A and B. So this is what happens. Now what happens after this? So after this, one of the three things will happen. First, there may be a case where A and B are made up of such kind of materials that are completely plastic, that don't want to go back into their original shape and size. So objects A and B, I can say that objects A and B do not even try to regain their original shape and size. No attempts from their side. So A is in a deformed state and it is happy like that. B is in a deformed state, it is happy like that. There is no attempt by A to regain its original shape and size back to become spherical again, or maybe whatever that initial shape was or size was, and there is no attempt by B to again regain that original shape and size. So such kind of a collision where the objects do not even make an attempt to regain their original shape and size is called a perfectly plastic collision or a perfectly inelastic collision. So the nomenclature is perfectly inelastic collision, or sometimes we say perfectly plastic. So both of these names. Now there can be another case, and in that other case the objects may try to regain back their shape and size partially. They may make an attempt, but they may not be able to regain their shape and size, their original shape and size completely. So what happens in those cases? Objects A and B regain their shape and size, let us say partially. So beyond this state, when A tries to regain its original shape, what it will try to do is it will try to push B further to the right. So until now it was applying a force on B to the right because it was moving faster than B. Now it is moving at the same velocity as B, so because of that factor there is no force by A on B, but there can be a force by A on B now because A wants to regain back its original shape and size. So this side, which has got deformed, wants to push to the right so that it can become exactly like what it was before. And when that happens, B will still keep on experiencing forces to the right. So beyond this movement also B experiences a force to the right, and A by Newton's third law, will experience a force to the left. And you can also say that that force is because B may try to regain its shape and size, but it is enough if one of them tries to regain its shape and size. So what happens is, beyond this state also, let me copy this, and beyond this state also, A is going to push B to the right. And if I draw one FBD of B, probably that FBD will look like this. So you will have this object B on which a force still acts in the rightward direction. And so what will happen is the speed of B will become more than U as time passes. And if you try to draw the FBD of A, you will see that the FBD of A will be looking like this, with a force in the backward direction, that same force. So still the forces will be F and F. I don't know what that F is, but whatever it is on B, that same F will be acting on A. And because of this F, A is going to slow down. So A slows down further, so its speed now becomes lesser and lesser and lesser than U. B speeds up further, so its speed becomes more and more than U. And what will happen is that B will speed up, it will try to move away from A. A will try to slow down, and this process will continue till they are in contact and they are trying to regain their original shape and size. But once they stop trying to regain their original shape and size and they leave contact, then after that they are going to move with those individual velocities. So let me say that here in this case, A further slows down, A slows down further, and B speeds up further, and finally A and B are not in contact. While in the first case, when the objects do not even try to regain their original shape and size, they would keep on moving forever with these velocities and always remaining in this configuration. So in the first kind of collision here, the objects did not even try to separate. So if I say that here, the objects never separate. They move together with the same velocity u forever after the collision. In the second case, the objects separate. Objects eventually separate, and B moves faster than A. So this is the second case that may happen. A third case is still feasible, where the objects A and B try to regain their shape and size and they are able to do it completely. So that's the third case. Third case is objects A and B regain their shape or size completely. This is the third case. Now this case will go ahead in the same way as the previous one. The only thing that will happen is that finally when A and B separate, they won't have any deformation. That means they would have been in contact for a longer amount of time than this case, and that means that they would have exerted these forces on each other for a much longer amount of time than the previous case where they were able to regain their shape and size only partially. So that means that the final velocity that B gains will be greater than what B would have gained in the second case, and the final velocity of A in this case will be lesser than what A would have had in the second case. So we can maybe make a guess like that, and we can say that A slows down to a velocity lesser than what it would have had in case 2, and B speeds up beyond what it would have had in case 2. So this is what happens. So I can maybe make a guess that in this case B will be moving faster eventually than whatever it would have been able to move in case of the second case here, and A would have been moving slower than what it would have probably moved in case of the second case here. So this is the entire mechanism of the collision. Now this third case, where the objects A and B are able to regain their shape and size completely, has got a special name. It's called a completely elastic, perfectly elastic collision, or sometimes it is only called elastic collision. So if they say elastic, they mean this kind, elastic collision. So we have got elastic, or the perfectly elastic collision, then we have got the perfectly inelastic or the perfectly plastic collision, and in between we have something which is simply called inelastic. So this is inelastic. When they say inelastic, don't assume that it is the first case. No, for the first case they will explicitly use the word perfectly. So if they don't use that word perfectly, then meaning inelastic will simply mean that it is maybe this case. And when they use elastic, that automatically implies that they are talking about perfectly elastic. So this is how a collision proceeds.